Thanks. Today, we're going to start with questions from the homeworks, if you guys have anything, which I think we might. It is very sticky in here. Yeah, that sounds right.
It wasn't due, right?
Correct. It was not due. I'm going to try my best to remember not to assign anything as due until we've had at least a day to check in and talk about things. So this is our first time talking about anything from Chapter 3 outside of the initial first day of lecture. You know what I mean? Feels a little bit more fair that way. Taylor?
I have a question. Just for the graphs. So
Yeah.
when I did this last year with Chun, he just had us draw like dashed lines for anything that was not one of the points that we did. Is that okay?
So like
here, I'll show you.
So let's just say, like number 1 or 9 here is like whatever, right? It's like just fill in the key points.
Yeah.
And so you'd be able to draw that much of it. From here, what I would say is I'd like to see like a point where you're extending to, but I don't need you to write anything additional down.
So you want the other points too?
Just on the graph, I'd like to see
So like
where the
this,
points are plotted at.
all one.
I mean, you're probably neat enough that I wouldn't mark you down for it, but I would like to see like the points.
I'll do little.
Yeah, you don't have to do anything crazy, right? But I would like to
Those
see.
are the dashed lines.
Yeah,
That's. I don't feel like we do.
No. I'm not going to worry about dashed lines or whatever. I'm just saying that like I just want to be able to see clearly see that. Because here's the thing that happens, Taylor,
Mm-hmm.
is like I'll get, people do this and then they'll do something like that. And it's like, it's just like, what am I supposed to do with that? It's like, okay, you're extending, but like, that's not what it looks like kind of thing.
I get it.
So if I can at least see the points that you extended, and if you're a little messy there. Now, from what you kind of peeped me, I mean, it was so neat that I couldn't have any issue with it. But some of us are like far less neat. And maybe that is a request for some of us that are a little bit more scribble-scrabbly.
Mm-hmm.
I was a scribbly kid. So. Raylan.
For the problems, like for the 5 and 6, I get the question. What does it mean when it's you say like on the interval -4 pi?
Oh.
For like the problems, not for the worksheet.
Oh, in the homework.
Yeah.
I see. Did I sign these things yet? I don't even remember.
I thought you did.
No.
It was just the worksheet.
I think just the worksheet, but that's okay. So we can talk about that. So it's asking us to graph something on that interval, right? So like, here's what I would say, Raylan, is see how on the worksheet my interval goes from basically -pi/2 to 4 pi. I would want, when you graph this, the interval to go all the way back to -4 pi. So you're just extending further, backwards. Does that make sense?
Yeah, that makes sense.
That's all it's saying. It's just like, that's the graph paper that I want you to put it on. Starts at -4 pi and goes all the way to +4 pi. And you just fill in everything, and that's all. You're welcome. Anybody else? Okay. That's fine. So last time I did a bad job talking about going from a graph to an equation. And I want to pick back up on that and try to do a little bit more of a coherent job. just having a bad day or whatever. You know what I mean, guys? Yeah, you guys are all looking at me like, what the heck is he doing? And I just was stumbling all over myself. We're just going to start it all over again and do a better job this time. Okay. Okay. So I'm going to just kind of divide my work, because I'm going to do this for both a sine function and a cosine function. So I'm going to try to stay a little bit more organized in doing this. Okay. So what I like to do to start is I like to find my k value first. So I'm just going to kind of look at the graph and look for the line that kind of divides it in half, because the midline is going to give me my k value. Everybody agree with that as the midline? And that's going to give me the k value for both versions, sine or cosine. So far, so good. Okay. Next thing is I'm going to find the amplitude. So the amplitude is like the distance from a max or a min back to the midline. So in this case, that distance is 3. The midline was at 1. That maximum was at 4. So 3 units to go from 1 to 4. Is everybody okay there? And the amplitude is the same for both. Notice here that I'm writing the absolute value of A. I don't yet know if the A value that I'm going to use is going to be positive or negative. There's infinitely many answers to each of these questions. So like there is an answer that's correct that uses A that's positive, and an answer that's correct that uses A that's negative. In a few moments here, when we get a little bit further in, I'll talk about how I'm going to make the decision as to whether I want to use a positive or negative A. But I'm not yet ready to make that decision now. Everybody still doing okay? The next thing I'm going to do is determine my period. So the period is the distance of one cycle. I usually like to do like extreme to extreme because they're easy to find. So that one is at negative 1/4 pi all the way to 3/4 pi. So that tells me the period is 1 pi. Everybody agree with that? Negative 1/4 to positive 3/4 is 1. And this is going to allow me to determine C, because I know that one period should be 2 pi times the absolute value of C. So that tells me the C is 1/2. Now again, I'm not saying that C itself is 1/2. I'm saying the absolute value of C is 1/2. Again, infinitely many answers. There's correct answers that have a positive C, and there's correct answers that have a negative C. With the C, though, I'm going to make the decision right now by choosing C to be positive. In my experience, I have rarely run into a problem where picking the C to be negative makes the problem any easier. Usually it's going to make it either the same or maybe even a little bit more tedious. So I'm just going to start by picking the c to be positive, because I know there is a correct answer with a positive c. And I'm just going to operate under that assumption from here on in both scenarios. Everybody okay to hear? Okay, this is about where the rails started going off where it started going off the rails for me last time. So to find the h and determine the sign on the a is typically the trickiest part of this. The way that I like to do this is I like to match up a point from the parent function with a point from this transformed function. Now, the easiest case for that is if the point I'm using from the parent function has an x-coordinate of 0. In a situation like this, where I can pick any points on the graph, I have all the points on the graph I have access to pick. It's very easy to force that hand. So that's what I'm going to do. So for sine, the parent function point that has an x-coordinate of 0 was 0, 0. And for cosine, that point was 0, 1. Now, if I go back and I look at the graph of sine, let me start with that one first. I'm just going to set it like over here somewhere. And I look at my key points. I had like 3 kinds of key points, right? I had a midline point. I have maxes. I have another midline point. And I have minimums. Everybody agree with that? Now, there's actually 2 different kinds of midline points. If I look at this first midline point, notice this one is preceded by a minimum and then followed by a maximum. If I look at this other midline point, it's preceded by a maximum and then followed by a minimum. Everybody see that there's really 2 different kinds of midline points here? It's important to note that, so I'm going to record that information on my work below, because it's going to help determine whether I'm using a positive a or a negative a. So the parent function had a midline point max. That was the type that we had there. And now I'm going to look on my transformed function and choose any midline point. So like I could pick this one, or 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 this one. Doesn't matter. So any of them are going to be fine. Let's say for the sake of argument we choose this one. Seems like an easy one to pick, right? 0, 1. Notice that this midline point is minimum followed by maximum. So because they are the same kind of midline point, that tells me that I want to use a positive a here. Is everybody okay with that? And then I get for free that the x-coordinate for my transform point is going to be my h. Let's explore that a little bit further as to why that's true. So remember from our parent function, this is the way we change to a transform function point, right? Everybody remember that map? So what this is saying is that c times the x from my parent function plus k should give me the x from my transformed function. So in our case, our c was 1/2. My pen stopped working. Come on, pen. There we go. The x from my parent function is 0. Oh, I'm sorry, that's not k, that was h. Plus h should equal the x from my transform function, which is also 0. So it just tells me h is 0. This is the piece of why I wanted to choose the point for my parent function that had an x-coordinate 0, because then the c doesn't really matter, right? Because whatever the x is for the transform function is just going to give me the h. On these problems where we have a graph and you can pick any point you'd like because you have all of the points available to you, I always like to do it this way because the h just comes up for free. Does that feel okay? Is this a little bit clearer than last time where I was a little bit all scattered all over the place? I'm trying much harder to be better organized here today. Okay. So that was everything we needed, right? For our sine function. So that's y equals 3 times sine of 1 over 1/2 x minus 0 plus 1. And again, you could just write 2 instead of 1 over 1/2. And in fact, I would encourage you on your work to do that. I'm going to write it as 1 over 1/2 here because they're notes. So you can see what's going on a little bit more clearly. You know what I mean? But I would hope you'd write that as 2 on your papers. Okay, let's do the cosine side now. So cosine, the parent function point we picked was 0, 1. This was an extreme point. There's 2 types of extreme points. There's maxes and mins. 0, 1 was a maximum. Let's just show you the graph of cosine again and just point this out. All right, it's probably nice to remind ourselves of these, what these look like again. Everybody's okay with that? So, for my transform point that I'm going to use, I can pick any extreme point. So I could pick like any of the maxes, or I could pick any of the mins. Doesn't really matter. For the sake of example, let's say we picked this one. Okay. So that is negative pi over 4, comma, negative 2. And that was a minimum. Since those are opposite, that tells me that the a is negative. And here, since the x-coordinate for my parent function was 0, the x-coordinate for my transform function is going to be my h automatically. And that's everything I needed. So I have -3 cosine of 1 over 1/2, write that as 2, times x plus or minus a negative, write that as plus, pi over 4 plus 1. And if you want to, you could even distribute the 2 through on these kind of problems and just clean it all the way up. Raylan?
Wait, so if you chose a maximum for the transform function, could you have done that?
Sure.
Made it, positive?
Yes. The h would be different because it's a different coordinate, right? But you'd end up with a different value of h, but that would also be fine. Just like the other problem here, if we had picked instead like this midline point, we would have ended up with a negative h. Or I'm sorry, negative a value and a different h. But that's fine also. It doesn't matter which ones you choose.
So what would the h be?
Whatever that x coordinate is, looks like pi over 2.
Okay. So then it would just be positive.
Yes, the h would be positive pi over 2. Yep, on that one. Yes. Does that feel a little bit better? Looking at it again? Yes.
How did you get the negative 5 over 4 and the negative 2 again?
So I just read off the coordinates for this point.
Okay.
So I picked an extreme point to match with the extreme point from the parent function, because I have to go, when I do that mapping, an extreme point has to become another extreme point, and a midline point would have to become another midline point. But a max could become a min could become a max, or max could go to max, or min could go to min. So any of those would be okay. Yes?
So about parent function, point 0, 1. What would be 0? We have a positive a. Why would we choose
Well, you can.
that? Yeah.
Yeah. It just, you need a negative a value then.
That's what I mean. Negative.
Yeah. Or you could have picked a maximum and kept the a positive,
Yeah.
and that would be fine also. Still gives you the correct answer.
But is our parent function coordinate if we pick a minimum still 0?
Yes. Because 0, 1 is an extreme point,
Yeah.
right? So there are two types of extreme points, maxes and mins. All you need is another extreme point to go to extreme point. It doesn't have to be the same kind of extreme point,
Okay.
because you can take care of the flipping with the a value.
Okay.
Just like with the sines, you can pick any midline point. It doesn't have to be the min midline max midline point. It could be the opposite order. And again, if you do that, you just take care of it with the a value.
And then for our y coordinate, isn't it something other than negative 2 because we have the 1?
The y coordinate does not matter, because we've already pulled out the a and the k already, so we don't have to worry about what's going on with the y coordinate.
All right.
Should we do another?
Okay.
Yeah, let's do another. So I'll just make one up here. That's okay with you guys. This one I had made ahead of time, so it worked out nicely. let's say that this is our graph. I'm going to organize things the same way. I'm going to make a column to do my work for the sine. And do a column for my work for the cosine. And let's just kind of talk through this together so you guys kind of help tell me what to do and what you want to do. And we'll do kind of what you want to do and do it the way that you want to do it. And we'll see how things work out. And I'll talk about how I adapt what I just showed you guys depending on what we're doing or what you're choosing, okay? So a little bit more a little bit more directed from you guys. So the first thing we want to do is look for what? The midline, which is the K. Great. Can you guys see from there what the midline looks to be? -2. I agree with that. Oops. Just cut straight to the chase, right? Feel okay? All right. What's the amplitude? Two. Everybody feel okay with that? Okay. What does the period look like? Try again. Yeah. So C is 2 in this case. Everybody's okay with that? I didn't write the equation down, but hopefully that's one that you could mental math your way through, right? Do I need to? I can if you'd like. It's no big deal. Okay. So far, so good, right?
You don't see it's 2.
Oh, jeepers creepers, thank you. Yeah, 2 is what I meant. I was right the first time. Yikes. Okay. Now let's find the H and fix our value for A. So again, for sine, I'm going to choose a midline point. So from our picture, it looks like I have 2 choices. Doesn't matter which one we choose. Which one do you want to pick? The first one or the second one? The second one, just because it has no negative sign on it. So that's pi -2. And if I look at that midline point, that goes max, midline, min. So what does that tell me about the sign for A? So that should be negative. And what does it tell me my H is? Pi. And that's everything we need. Oh, because we always pick the C to be positive. I guess I forgot to box that up. So y equals -2 sine of 1/2 x minus pi -2. Does that feel okay? It's not so bad, right? And in fact, because we're able to pick any point we want, we're not forced to use certain points. It actually makes the problem much easier. The next thing we're going to do is we're going to look at descriptions of graphs, where you're only getting some of the information, not all of the information. and do the same thing, and that's a little bit more challenging, but still pretty doable. Okay, let's do the cosine side. So the parent function point for cosine that we like to use is 0, 1, which is a maximum. So for my transformed function, let's pick a point. So again, here we could do any of these 3 extreme points. 1, 2, or 3. Which one do you guys want to use? 2, okay, which is at 0, 0. That's a good one to pick. That's a maximum. So because these are the same, that tells me that the A is positive. And then the y, or the x coordinate here is my h. And the c again, we're always going to choose to be positive. True. Dunzo funzos. Okay, you guys feel okay on doing this, or at least better? I feel like that was a lot clearer what I was trying to do here than what I was trying to do last time. So that's good. Okay, so let's do some description to equation. Examples here. Okay. So let's say we just want to write a sinusoid that has graph has an amplitude of 3, its period is 6 pi, and it passes through the point -10, 6. This is the easiest possible version of this kind of a problem. So from the amplitude, what can we get? Yeah. Now we're going to get that the absolute value of A is 3. We're not sure whether it should be positive or negative yet. We'll talk about that in a minute. What can the period give us? C. We know that 2 pi times C is equal to the period. So here our absolute value of C is 3. Everybody feel okay there? So what does this point here left have to tell us? John?
Whether we pick sine or cosine, we have to get our midline or one of the extremes to do that.
Yeah, so somehow this final point needs to be whether we're going to do sine or cosine. It's going to have to give us our h and our k, and it's going to have to give us the sine on the A, and well, the C will always pick to be positive, but or at least I do it that way. Everybody okay with that? Now, in this version, let's go ahead and show you one doing it with sine and doing it with cosine, because you can do either one. You can still get the correct answer either way. One of them significantly easier than the other, though. So let's do, say, sine first. So from my parent function, what value for sine is the best one to use? 0, 0. And my transform function has to go to this point, right? Now, do I know anything about the type of point negative 10, 6 is? No. Does it matter what type of point it is? No. So I'm just going to make it the exact same type of midline point as 0, 0 is. Because, well, I'm not told that it has to be anything different. So my A is just going to be positive 3. My H is going to be negative 10. And guess what else? K is going to be 6. Because the y coordinate is on the parent function is also 0, the y coordinate then should give me the k also. John?
For our age value, we have to simplify, like, what's the parentheses after? Like, we have our 1/3 x, or is it?
So, yeah, so I wouldn't be too super picky about that, right? If you wrote it this way, or if you wrote this, I don't think I would mark down one way versus the other, unless the directions specify to do one thing versus the other, but they're both correct. We're just arguing about, like, you know, the point of the hard part is writing the equation, right? That's the thing that I really want to test on. I'm not really concerned about simplifying. I mean, if you simplify wrong, I'll mark it down, but because you did, you know. Okay. Let's say that instead we had chosen cosine. So if we do that, the parent function point I usually use is 0, 1, which is a maximum. We're going to go to the transform point negative 10, 6, which we're not told what it is, so why not just choose it to be a maximum? Margot? Absolutely. Right? We'd have the freedom to pick negative 10, 6 can be anything we want it to be, a maximum point, a minimum, a midline point, any type of midline point. So just, I like to pick them so that the A is positive. And since the x coordinate here is 0, I know the h is negative 10. Here's the lousy part, though. To get the k, I have to do a times the y from the parent function plus k has to equal 6. So the formula that I use there is that, right? A times the y from the parent function plus k equals the y from the transform function. So there, k would be 3. Now, if it doesn't specify whether I want a sine or cosine function here, which one was easier to do? The sine. Is everybody okay with what I did there? Okay. Okay. So same problem, except here we're told that that point negative 10, 6 has to be a maximum. So I'm just going to do that stuff without actually showing any work, right? Since it's the exact same as it was before. Everybody's okay with that? Here, if we're told this point is a maximum, which function would be easier to use, sine or cosine? Cosine, I would agree. So let's do the cosine version, and then we'll come back and do the sine version afterward, just to show, like, okay, if I would have picked sine, like, why was that harder? And it's not a lot harder, but it's like a little bit harder. I guess here we're going to still pick C to be positive. And then still have to do the same thing we did before with solving for K. Do you guys mind if I just stop writing the final answer after I block off what the H's and K's are? You guys are good with me just quitting doing that? Okay. So that's virtually identical to the previous problem, right? Where we picked that point to be a maximum anyways. Same exact work. Here's the catch with sine. If I'm using sine, I have to pick a maximum or minimum from the parent function to use. So let's say I picked pi over 2, 1, which is my maximum point, to go to this maximum. Well, I know that the A is positive, but now I have to solve for both the H and the K. That's going to be negative 10 minus 6 pi over 2. Yuckarooskies. And then K equals 3. Of course. Okay, you guys ready to do another one? Did I lose you anywhere? Taylor, are you raising a hand? Just need a second to think?
Yeah.
Okay. Allison? Or Alyssa, sorry.
How'd you get the negative 6 pi?
Oh, that should be 3, right?
Yeah.
Jeepers creepers. Yeah, good point. Taylor.
Are we able to like put that together for each?
I mean, you could write it as like negative 20 minus 3 pi all over 2. You could do that if you wanted to.
How do you like put that into the equation?
You just write as that whole thing.
But then with the c value, what does that do to it?
Oh my gosh, come on. So we have 3 times sine of 1/3 x minus, and I'm just going to write it as pluses just to make life a little bit easier. And you can distribute the 1/3 through, but it doesn't make life much nicer. You know? And just this was going to be a crummy answer for sine, right? Like, look at how much nicer cosine worked out than choosing sine in this case, right? Alyssa.
For when you get the answer, is that negative 10 times?
That's a minus. Negative 10 minus 3 pi over 2. Ugh, come on, you stupid. My pen is just like, stops responding all the time. It's making me so angry. There, that's a little bit more clear, right? Yeah, no problem. These are all good questions. Like, if you can't read it, it's hard to see what's going on. John.
Is there going to be a time when you tell us which trigonometric function to use? Or
I could.
you could tell us to use sine for min or max.
Yeah. Yeah. Let's do another one. Sound good?
But will you give us the points, or do we have to memorize?
You'd end up on a test or whatever. I would have given you the key points with the graphing, right? Because you're going to have to be graphing. Oh my God. What are we doing? Why is this doing this? Okay. Let's say we want to draw the sinusoid that passes through or that has a minimum at negative 2, 3 and a maximum at 4, 11. When I do something like this, the first thing I'd want to do is to kind of just sketch a little bit of a picture. Everybody okay with the picture that I sketched? Now, did I know that these were consecutive maxes and mins? No, I wasn't told that, but they could have been, right? So I'm going to make them. Taylor?
Is that point, is the point negative 2, 3 or negative 2, negative 3?
Oh boy, that's a good point. I am gonna smash this stupid stylus. You know what I should have just done, Taylor? This is the smart math teacher. Watch this. Right there. That's how you know you're a smart math teacher. I'm not going to erase the whole thing. I'm just going to move the axis so now it looks right. But yeah, it's an excellent point that I definitely plotted something that made no sense, right? Okay. So I'm going to start first by finding my k, right? My k should be something like this, which is going to be the average of my y coordinates. Everybody's okay with that idea? Okay. The next thing we'll find is our a, which you could think of as the difference, or half the difference in your y coordinates. Or once you had your k, you could just really kind of count, right? 7 going up to 11 is 4, and then down to 3 is 4. Either way of doing it, though, is fine. Everybody's okay with that? And again, if you wanted to do that visually, you could really kind of do that visually if you drew a nice graph. Right? Just like we had done before. Now, what we're going to do is find the c. So going from here to here is how much of a period? Looks like half, right? And 1/2 of the period is going to be the difference in the y coordinates. So I have 1/2 of 2 pi times the absolute value c should be 6. Taylor?
For the absolute value of a, is that 11 minus 3?
Yes.
Okay. But then why is it 11 plus 3 for the other one?
So the k is like in between, right? So it's like the midpoint. That's why we're adding, like taking an average.
And then
The a is the distance between the midline, so that's why we're subtracting and like finding a length.
Okay.
Does that feel okay?
Yeah.
You just stretching?
Yeah.
Okay. So if I go ahead and do this, I get c is 6 divided by pi. Everybody's okay with that? So, yeah, of course. Sine or cosine, which one would be easier? Cosine. Why? Because we have maxes and mins. We don't have any midline point.
Could we find the midline if we find the difference between the axes?
You could. That's more work than I'd want to do, though. Just one more thing for me to potentially mess up. So for cosine, I'm going to use my maximum 0, 1. And where should I send that to? Does it matter? Not really. Maybe I'm going to use 411 because that's also a maximum. So it tells me the a should be positive. and the h should be 4. And obviously the c's we're always going to use as pi over, or the positive. Had I used sine, well, maybe I'll do max to max here. So I have 6 over pi times pi over 2 plus 8 should give me 4. So that would be the only difference there with my sine answer. Ugh. Question for you guys. When you're using your OneNote, do you ever get a situation where like the stylus is like writing without touching the screen? Because that's what's happening to mine right now. I think it's really, I'm just having a bad stylus day. That's why everything is so messy right now. Not that my penmanship isn't messy ordinarily. Everybody's okay with that? The tricky part there was the period, right? Was really what made that one tricky. I mean, the amplitude and the midline, yes, those were a little bit tricky, but they weren't so bad. I think we're just about done, aren't we? This seems like the best place to stop here. So from here, you guys should be able to do worksheets 2 and 3. And again, our next class on Wednesday, is not an in-person class. It's a virtual asynchronous class. I've already made the lesson for that. So you can see the notes here already in the content library. It's just more examples of what we just did here together. So you could skip those if you really didn't, if you're like, I got what I needed to. But it's like 15 minutes, just me working through some examples, kind of like what we just did here. And then you're just going to work on those worksheets 2 and 3. Everybody feel okay with that? So the homework for this week is just going to be the worksheets, or that worksheet 1 is the only homework assignment for the 10th. Those next 2, since we won't have a chance to meet and talk about them before they're due, I'm not going to have due till the 17th. Everybody okay with that? So another light homework check week for you guys, but I don't think anybody's going to get too upset about that.